Hi, doing a quick video on chapter 4.6, graphing a cotangent function. Alright, so let's look at some generalities with the cotangent function. We notice that if y is equal to cotangent, we have the units, so when the unit circle, if cotangent, or an identity I should say, cotangent is equal to cosine over sine. So when we graph these, what we're looking for is when is the sine value equal to 0. So because that's going to be where cotangent is undefined. When we looked at tangent, there were other possibilities there. We wanted to find out when cosine was 0 because tangent is sine over cosine. But now we're dealing with cotangent, so we get a new set of guidelines here. Natural occurring asymptotes are 0 and pi. We notice the graph that it rises to the left and falls to the right. Our natural occurring asymptotes are at 0 and pi. Normally a period is pi for these, and so we look at an example. That's the general. Now let's look at an example where we might be shifting some things, and we do in fact in this example. Example number 1, y is 2 cotangent of 2x plus pi plus 1. So we've got some things going on here. Amplitude is 2. Remember, amplitude determines where does that shoulder point go. So how high in the y-axis does that shoulder point go, or how low does it go? So we find out that the period, we'll look at the period in a second. The period for this one happens to be pi over 2. But the phase shift of negative pi over 2, vertical shift of 1. So remember, out here, this is your vertical shift. If we wanted to note the general equation, again, it's y equals, we've got some a value, which is our amplitude, times the cotangent of bx minus c plus some d value. That d value is the vertical shift, and then you've got your bx minus c, bx minus c, where again, a is the amplitude, a is amplitude. It really just determines where these shoulder points go. And D is a vertical shift. So D is a vertical shift. Okay? So that's how the graph moves up or down. So here we go. Let's continue on. I wanted to give that to you. So we have an amplitude of 2. We've got a vertical shift of 1. We fill that in our space here. And now what we've got to do is we set up our graph and we list the 5 key points. We have the left asymptote, the left shoulder point, the 0, the right shoulder point, and a right asymptote. So what we have to do is we have to figure out, well, where are those asymptotes? So again, for that phase shift, we are going to set that bx minus c equal to 0 and pi. Those are our 2 naturally occurring asymptotes. So here we go. 2x plus pi, we equal 0. We subtract pi. We get 2x is equal to pi, negative pi. And x is finally equal to negative pi over 2. That's our first left asymptote. For the right asymptote, we set it equal to pi. So 2x plus pi is equal to pi. Well, when we subtract pi, that goes to 0, and so we get x is equal to 0. So we can fill those in. We've got left asymptote of negative pi over 2, right asymptote of 0. Now, we have to figure out, well, what's in between 0 and negative pi over 2? Well, negative pi over 4. This is the time you can get out your unit circle and start looking at these things. But now, we get between negative pi over 2 and negative pi over 4. We're like, wow, what is that? So, you got to try and figure it out. Negative pi over 2 plus a negative pi over 4. And then we're going to take half of that. So we need a common denominator of 2. So we multiply 2. That gives us negative 2 pi over 2 minus pi over 4. All right, let me turn around this way. That gives us a negative 3 pi over 4. We take that times 1/2. Once we do that, we get 1/2. Or that equals negative 3 pi over 8. And we can't simplify 3 and 8, so that's what we get. And our left shoulder point then is at negative 3 pi over 8. And our right shoulder point, well, halfway between negative pi over 4 and 0 is going to be negative pi over 8. Just take half of negative pi over 4 and you'll get that. Okay, so now we're ready to graph. I've got my 0 laid out. My new 0 line is up 1. So my new 0 for when I go to fill in the 0 here, that's going to be based on that line. And then up top we have our left shoulder point. Or this is where our shoulder point goes. And another shoulder point here. So, and now we draw the curve. All right, so kind of our maximum and minimum numbers. So let's see. We have our left asymptote. That's already drawn in the red. We have our right asymptote. That's drawn in. That's at 0. We have our places where our shoulder points should go. So now we got to do is just draw the curve. At negative 3, 8, we know that the natural curve for a cotangent is rises right, falls, or rises left, falls right. So I'm going to put my left shoulder point there. My new 0, don't forget, will not be on the regular 0 line. It's moved up 1. So we've got to put that there. And then my right shoulder point is at negative pi over 8. And that's going to go right where that 8 is. So I apologize for that, but that's all right. And then we're going to see this curve go like this. And then down that way. And that is a nice cotangent curve. Hope you've enjoyed that. Rewind it. Go back through it. Check it out again. Have a great night. We'll talk to you soon.